Good evening, everyone. So today is the week 10 session for the NPTEL course Environmental Geomechanics. We are going to solve the previous year assignment questions and see how it and solve it together. So first is that which of the following strategies can be employed to immobilize contaminants? Now, of all these, we see what so first is what do we mean by immobilize. Immobilize means that we make sure that there is no movement of contaminants. It means if this is a geomaterial and somewhere here we find that are contaminants present, then before they move in any direction, what we do is we have to pack them so that they will stay there, but they will not harm the geomaterial, they will not affect the geomaterial. So let's look at the options. First is adsorption. So adsorption cannot help in immobilization. In fact, it will help in mobilization, right? So it actually helps in making contaminants move by adsorbing onto the other on the surface of geomaterial. And same goes for absorption. Now, what is left is vitrification. So, vitrification is, in simple term, is conversion into glass, or what it does it convert the geomaterial into glass, not actual glass, but what we do is we if there is a sudden increase in temperature followed by sudden cooling, so what happens is that it actually pack the contaminants it's in its place. So that is vitrification. There is a sudden increase in temperature and then there is a sudden cooling, and it leads to the formation of vitrified rock. So it also happens in volcano. So when there is a volcanic eruption, so when the lava comes from beneath the earth surface, it has a very high temperature, and as soon as it reaches the earth surface there is a sudden change in temperature, it suddenly cool down. And if the temperature difference is very high, we see formation of glass like rocks. Okay, for example obsidian. So when there is a sudden change from high temperature to a sudden cooling, we get vitrified rock, and then it helps in immobilizing the contaminants. So answer is vitrification. Now next question is about the KD. So KD is just a second. Okay. Uh, so KD is sorption coefficient, or uh, it is used to determine the sorption, that how much sorption is happening in a soil or any geomaterial. Okay, so it is also defined as CS by CW. It means that if there is a solute, in this case, in this case water of around 12 liter has initial concentration of NaCl about 50 mg, but once it passed through the soil column, which has a weight of 8 kg, the NaCl concentration reduces to 30 mg. And now we have to determine how much NaCl is sorbed by the soil. So CS is solute which is sorbed by the soil. Okay, so solute sorbed by soil divided by solute left in liquid. In this case it is water. That determines the KD. So and it is also equivalent to so this is mg per kg, that is how much mg of solute is absorbed per kg of soil and how much mg of solute was present per liter of water. So in this case, how much, if after include, if initial concentration of NaCl is 50 mg and after passing it turns 30 mg, then how much is sorbed by the soil? 50 minus 30 mg. And what is the mass of soil, which is 8 kg, divided by, now this is left in the solute, in the water, right? So 30 mg is left in water, and how much water is there? There is 12 liter of water. And when we solve this for kd, we got 2.5 by 2.5, and answer is 1. Okay, so 1 and mg per kg, um, sorry, mg liter per mg kg, because this liter comes up and this kg comes down. So mg liter and mg per mg kg is the kd. So 1 mg liter of solute uh, per 1 mg kg uh, is the kd of soil, or the sorption of the soil. So answer is 1. Now question 3 is, which of the following exhibit a higher kd value? Now sorption depends on a lot of things, a lot of parameters. So one of them could be surface area, another could be density, right? So when we look at surface area, if a compound or if a geomaterial has higher surface area, it means there is high sorption, there is high chance that it absorb a solute or a contaminant, whatever. Similarly, if it has low density, it means it is less compact. It means there is a high chance of sorption compared to if it is very compact. So in this case, between sand and clay are have more surface area, so there is a high chance of sorption. Now, if we took so answer could be B or D, but we look at the density, we see that the less dense clay have higher uh, sorption sorption coefficient compared to the high density clays. Okay. Now we move towards question 4. Again, it is about which of the following parameter the adsorbate does not depend on. The sorption coefficient does not depend on. Okay, so adsorbate is something that is absorbing on a surface. So it is the solute. So compaction density I discussed earlier. Yes, it depends on it. Weight, not very much, because kd value does not depend on the weight of the solute. Specific surface area, it is not solute. It is. So specific surface area, yes. Mineralogy, yes, because clay minerals have high cation exchange capacity, so they are high adsorbing as well. And concentration, yes. So it does not depend on the weight of the adsorbate. On the other hand, it depends on the concentration of adsorbate. Okay. Now next is BTC, which is the breakthrough curve. So when we look at BTC, it is somehow like this in the lectures, which is Ct by C naught, and this is against time. So what the whole scenario is that if we have, let's say, a block of geomaterial, and if this is the initial concentration of, let's say, a contaminant, let's say ink, and after time t, here we again measure the concentration at time t. Okay, now if we plot Ct by C naught, which is the final concentration upon initial concentration with time, we see a breakthrough curve. And here Ct by C naught always has to be less than 1. Okay, it can never go above 1. Okay, so so now it is they are asked based on sorption and desorption. So for sorption, if we see one more thing, so sorption means that sorry, sorption means that there is a the soil is absorbing or adsorbing the compounds. In that case, the CT can never go above. So in any of the cases, in fact, even if there is adsorbent, even if you are removing the material, or even if you are injecting, the final concentration can never go above the initial concentration. So this always greater than 0 can never happen. Okay, so it can never go more than 0, more than 1, sorry. And so D is correct, where Ct by C naught can never be, in this case, Ct will never be greater than 1, and Ct by C naught will never be greater than 1, because the final concentration can never be more than the initial one. And for desorption, it is always has to be less than 1. So answer is B and D. Now the question is about what which of the following thermal property is, yeah, are main indicator of heat accumulation in a geomaterial. So when we discuss about the thermal properties, there are three which we discuss. One is resistivity, opposite of which is conductivity. Uh, and then there is specific heat, and there is diffusivity. So resistivity is that how much resistance there is, or to transmission of the okay. So resistivity is that if there is a soil mass, and here you are supplying heat on this end, and how much it is resistant to the movement of heat from this end towards this end. That is the resistivity. If it moves freely, it means the geomaterial is conductive. And it is also diffusivity, that how easily the heat diffuse through the soil material, right? And specific heat is that with change in temperature, right, how much change in the heat is so how so as we know, specific heat is that how much heat is required to change the temperature of 1 gram of a substance. Okay, so how much heat is required to change the temperature of 1 gram of a substance to 1 degree Celsius, right? So it depends, the specific heat depends on the mass and temperature. So and of course there is coefficient. uh, so in this case, so it means something which has high, it says that a geomaterial that can accumulate heat. If it can, it has to accumulate heat, it means its conductivity should be low. So in this case, high conductivity, no. And resistivity should be high. There is no, so resistivity, low resistivity, no. It should be high resistivity and low conductivity. Next is specific heat. Yes, it should be high, because if specific heat, which is Cp or Q, is high, in that case, if specific heat is high, it means there is increase in temperature, or there is high temperature per unit mass. Okay, more temperature per unit mass. And low diffusivity means there is low transmission of heat. It means it can get accumulated, or it can stay for a long period at one place. So these both are the answer: high specific heat and low diffusivity. Next is soil exposed to high temperature might undergo. So if you increase the temperature, the moisture content decreases, and if moisture decreases, then what happens is that soil become dry and it start developing cracks. So cracking will happen, and soil has organic matter, and this organic matter is susceptible to temperature. So with increase in temperature, organic matter should also burn. So answer is both A and B. Now for question 9, it's about the thermal flux in the geomaterial, and it says that the passage of thermal flux does not depend upon. So flux if uh, is how much heat there is per unit mass per unit surface area. So okay, so it depends upon the mass and surface area of the material, right? So thermal flux depends on mass and surface area of the geomaterial. Hence, it does not depend on the thermal conductivity. So answer is thermal conductivity of okay. Next is thermal diffusivity of a soil mass should be dash for the safety of the buried electric cable. So if there are a lot of cable, electric cable beneath the earth's surface, and if because of overheating they start, if there is overheating happening, then what happens is that, because if the thermal diffusivity is high, then the heat will transmit or diffuse itself to the geomaterial or to the soil, and hence there is less chance of short circuit or um uh, any fault in the wiring or in the electrical cable. Hence, this thermal diffusivity should be more, so that the buried electrical cable are safe, because high diffusivity means that there is a transmittance of the uh, heat throughout the media, and hence avoid the breakdown of the cable. Next is heat sink fluid. So when sir discussed about the thermal probe, he discussed that, let's say this sort of um, a thermal probe apparatus is there, and you are putting a thermal probe inside it. Okay, and now in here we put this heat sink fluid. This heat sink fluid should have high thermal conductivity, because when you put this into the soil, okay, so what it does, it check on the temperature of the soil and determine that, and see how much the temperature is changing. So to understand the temperature of the soil, uh, this is of copper, right? So when this thing touches the soil, this heat, because of its high thermal conductivity, will detect the temperature, will adequately transfer the temperature to the probe, and hence help in better detection. So this heat sink fluid should have high conductivity. Now match the following. We have to match the instrument with the type of identification they do. So first is thermal probe. We have seen it is for the thermal resistivity or thermal conductivity. MIP is a mercury based porosity meter, and hence it is used for the porosity. Uh, Now FDIR frequency probe is actually used for the magnetic field analysis, and hence it is used to measure the dielectric constant. And impedance is electrical resistivity, and it is actually analyzer is used to measure the resistivity, electrical resistivity of the soul. So answer is uh, B, C, and B, A. So answer is B. Now, Question 13 is, which of the following properties, which in which case thermal property of geomaterial and water are approximately same? So first is that about we talk about the dry density. The thing is, dry density has no effect on the geomaterial property. So in the literature there is there is a plot which says that with change in the density or dry density, uh, and there is, let's say, any thermal property, they generally don't change. Okay, they are just flat lines. So it density has no effect on the thermal property. Now SR is degree of saturation. So it means, and degree of saturation can be less than equal to 1. It can never be more than 1. Saturation cannot be 110 or 200%. It has to be 100%, right? So it cannot be more than 1. Now, so in this case, when SR is equals to 1, it means the soil or geomaterial is completely saturated, and SR less than 1 means that geomaterial is partially saturated. So when the answer should be when it's completely saturated, because when the geomaterial is completely saturated, in that case we can measure the thermal property and we can find that they have the same thermal property for both water and the soil or geomaterial. Okay. Next is the thermal resistivity. So we know that water has high thermal conductivity. It means low thermal resistivity, and soil has not so high thermal conductivity and should have high thermal resistivity. So in soil has higher thermal resistivity compared to water. So for today we are done. Thank you.